Okay, in this video I'm going to teach you all about surds and how to simplify expressions. Okay, now these are quite tricky. They're at the top end of GCSE and you need to be able to do these as soon as you start your A-level course. So this first expression here, we've got to simplify it. And what we are needing to do is recognise that if we look at each term here, what's the common factor of those three numbers, and such that the other factor is a square number? Well, 24 is the same as 6 times 4, 150 is 25, 6 times 25, and 96 is 6 times 16. So they all have a common factor of 6. And the other number I said in each case was a square number, okay? And that is our starting point. So if we now write this out as the root 24 is root 4 root 6, okay? So root 4 root 6. I'm just going to write this in full under here, okay? Root 4 times root 6. The root 150 is root 25 root 6. Okay, and finally the last term is 2 lots of root 16 times root 6. Okay, because root 16 times root 6 is the same as root 96. Now, the common factor is root 6, and the bits under the other square roots are square numbers, so they're easy to square root. Okay, so I simply now need to take that as 2. I'm just going to put these numbers outside and the root 6 on its own outside the bracket. So I've got 2, which is root 4. Root 25 is 5. Okay, and then I've got 2 lots of root 16, which is 2 lots of 4, which is 8, minus 8, of course. And the common factor of all three of those terms was root 6, so I'm putting that outside the bracket. Okay, and now you can see that that's 2 plus 5 minus 8 is minus 1. So it's minus 1 root 6. We don't write the minus 1, we just write minus root 6. And that's the answer to the question. Okay, if you were to put that into your calculator and put equals, it would simplify it for you and give you this, okay? Because it will always write the simplified surd answer for you. However, in an exam question, it would likely ask you to show that that is equal to something, or show all your reasoning or working, and that's what you would need to write down, okay? Now, the next question here, we use FOIL, first, outer, inner, last. So we take the first terms and multiply them together. 3 times 4 is 12, okay? So I'm just going to write that down there. And then the outer terms, 3 times root 2 is 3 root 2. Okay, now the inner terms will be those two there. So that's 4 times root 8, negative, so it's negative 4 root 8 or minus 4 root 8. And finally, the last terms is the minus root 8 times root 2, which is minus root 16. Okay, I'm just going to write that down in full. Okay, well, of course, root 16 is 4. So that last term is minus 4. So if I just change this order around a bit, I've got 12 minus 4, okay, which are what we call rational numbers, okay, because they don't then contain a square root. And then I've got 3 root 2 minus 4 root 8. Now, you should know that they can both be written in terms of root 2. So I've got plus 3 root 2. Okay, and the root 8 is actually root 4 root 2, okay, which is 2 root 2. So I've got minus 4 lots of 2 root 2, which is minus 8 root 2. Okay, now if I simplify that further, 12 minus 4 is 8. Okay, and 3 root 2 minus 8 root 2 is minus 5 root 2. And that's my simplified answer. Okay, and normally these questions will contain one rational number and then an irrational part, which is the surd. Okay, next one. To get this answer here, I have to do something called rationalizing the denominator. Now, I multiply this whole fraction by root 54 over root 54. Okay, and by the way, putting that little dot is just a shorthand for multiplying the two together. Okay, now if I do that, what will happen is it will cause the denominator to become a rational number, because when we simplify surds, we don't leave an answer with a surd on the denominator. Okay, so that's the first thing I would do here. There's other ways you could approach this because the root 54 itself needs simplifying, but we'll come to that later. Now 3 times root 54 is obviously 3 root 54. Okay, and on the denominator I have basically got a root 54 and a root 54 multiplied together to give me 54, times all that by 2, I get 108. Okay, so I no longer have a surd on the denominator, which is what I wanted. Okay, go across to the next step, and I'm going to now recognize that the 54 is actually the product of a square number 9 times 6. Okay, so I can write this as 3 lots of root 9. I'm just doing it in full because I'm explaining what's going on. Root 9 root 6. So the 54, root 54 rather, has become root 9 root 6. The denominator is still the same, which is 108. Okay, and hopefully with your knowledge of your times tables, you can see there's going to be quite a bit of cancelling out in a minute. Now, root 9, of course, is 3, so that becomes 3 times 3 is 9 root 6 over 108. So 9 root 6 over 108. Okay, and you should know that 9 12s make 108, so that is actually root 6 over 12. Okay, and that can't be simplified any further. Okay, you might be looking at that thinking, well, root 6, there's a common factor 6 and 12, but it's root 6, you see, which is root 2 and root 3, and this 12 isn't rooted, so there's nothing you can do to simplify that any further. Okay, if you were to put that on the calculator and put equals, it will give you root 6 over 12. Okay, question, the next one. Well, there's several ways you could do this. You need to find a common denominator. Okay, what I would do here is I would recognize that first of all as root 9 root 2 and root 16 root 2. So a common factor on the denominator of root 2, and I'm going to rewrite it like that first. Okay, so I'm going to write it as 1 over 3 root 2. Okay, plus 1 over 4 root 2. Okay, now having got to that stage, okay, I could see that the common denominator is going to be 12 root 2. So to turn that into two fractions with a common denominator of 12 root 2, I'm just going to write that denominator first. So 12 root 2, and the other one also with a denominator of 12 root 2. Okay, So again, I'm putting all the steps in to show you what I'm actually doing here. So they're the two denominators, which are now common. Okay, well, I just say, well, what have I had to do to the first one to get that? I've had to times the denominator by 4, so 4 times 1 is 4, and this one I've had to times by 3. Okay, so combining that together, I get 7 over 12 root 2. Okay, 7 over 12 root 2. And I now have to rationalize the denominator by timesing it by root 2 over root 2. So if I just put that there, root 2 over root 2, that will give me a denominator that's now a rational number, and that gives me 7 root 2 on the top, and 7 root 2 on the top. And underneath that, I'm going to get 2 times 12, which is 24. 7 root 2 over 24. And that's my simplified answer to that question. Okay, last one on there. Okay, in this question here, we're going to multiply the numerator and denominator by 7 plus 4 root 3 over 7 plus 4 root 3. Okay, so it's like the opposite of this one. Now you'll see what happens when we do this in a moment, okay, and why we do it. And effectively it will cause the denominator to become a rational number. All right, so I'll just show you what we're actually going to do. We're going to times it by 7 plus 4 root 3 over itself. Okay. Now, I'll show you first what happens on the denominator, because that's why we do this. This dot here is just shorthand for multiplication. So we've got on the denominator now, all right, if we do first outer inner last, this is what happens, you see. First, 7 times 7 is 49. Right, now the outer would give me 7 times 4 root 3. And the inner would give me 7 times minus 4 root 3. Well, they cancel each other out. If you add the outer and inner together, you'll get 0. So you're left then with the last term, which is 4 root 3 times minus 4 root 3, which is minus 16 times 3, which is minus 48. So you can see now that the denominator is simply 49 minus 48, which is 1. So it's no longer got an irrational part to it. And that will always happen when you apply that rule. Okay. On the numerator, however, that will be irrational. So we've got 2 root 3 times 7. Well, that's 14 root 3. Okay. And on the other side of that, we've got 2 root 3 times 4 root 3, which is 8 times 3, which is 24. Okay, so the final simplified answer is going to be 24 plus 14 root 3. All right, we tend to write the rational part first and then the irrational part. You don't have to, but it's normal to do that. 14 root 3, and then underneath, as I've already said, we just have the number 1, so we don't even need to write it because it's not, it's just 1, and that's it. So that's the simplified expression for that. And if you put that onto a calculator and pressed equals in natural form, it would give it to you like that. Okay, next question. Here is a sort of problem solving type question. You've got a rectangle, you're told that the area is 6. Okay, so if the area is 6, I'll just do this in a different colour, I think, because we've got all this red stuff here. So if we have an area of 6 and we divide it by the width, it will give us the length, won't it? So that's what I'm going to do. I'm going to say that the length is equal to the area divided by the width, which is 3 root 2 minus 3. Okay, so then I'm going to do exactly what I did in this question here. I'm going to multiply the numerator and denominator by 3 root 2 plus 3 over itself. Okay, so 3 root 2 plus 3 over 3 root 2 plus 3. And that will give me, on the numerator, 18 root 2 plus 18. And on the denominator, okay, that will give me, let me just put the fraction line in. That will give me 9 times 2, because it's root 2 times 9, that's 18, and minus 3 times 3 is 9. Okay, that should be 18 minus 9 there. Okay, so that simplifies quite nicely. You can take out the factor of 9 all the way through that, and it will give you 2 root 2 plus 2, won't it? 2 root 2 plus 2. I'll just write it like this. It's 18 lots of root 2 plus 1. Okay, I'm just showing you how I've got that answer over 9. Well, of course, 18 over 9 is 2. So it's 2 lots of root 2 plus 1, which is, putting them the correct way round, if you like, 2 whole ones plus 2 lots of root 2. Okay. Putting the rational part first and the irrational part at the end. And that's it. And that's the length of that rectangle. So if you took that answer there, okay, and you multiplied it by this expression here, it will come to 6. Last question, we've got an equation to solve, okay, and we're just going to multiply out the bracket first. So I'm going to write 3x equals x root 5. We tend to put the x in front of the square root sign. Okay, x root 5 plus 2 root 5. Okay, I'm now going to subtract the x term from both sides. So we've got all the x's on the left. Okay, and you'll see why in just a moment. 3x minus x root 5, okay, equals 2 root 5. And the reason I've done that is because I can now factorize out the x from the left-hand side. So I have a single x term in the equation, so I can solve it, you see. So it's 3 minus root 5 times x, like that. Okay, and now if I divide both sides by that bracket, I'm left with x on its own, which is what I need to find out, you see. So x is 2 root 5 over 3 minus root 5. Okay, 3 minus root 5. Now, using the same techniques we used in the previous two questions, I'm going to take that fraction that I've just written down there and multiply it by 3 plus root 5 over 3 plus root 5. Okay, so I'm going to times that by 3 plus root 5 over itself. Okay, and we will end up with a rational denominator, as we did before. So that gives us, well, let's do the numerator first. So 2 root 5 times 3 is 6 root 5. Okay, and we've also got root 5, 2 root 5 times root 5, which is 10. Okay, so it's plus 10. And then on the denominator, well, the first term gives us 9, 3 times 3. The outer term and inner term is 3 root 5 times minus 3 root 5, which is 0, as we expected. And the last term is minus root 5 times root 5, which is minus 5. So I've got 9 minus 5, which is 4 on the denominator. Okay. And now I just notice, hopefully, that there's a common factor of 2 in all of the terms. So that's equivalent to 3 root 5 plus 5 over 2. 3 root 5 plus 5 all over 2. Okay. Now, if you look at the question carefully, they're asking you to present the answer in a particular form. Yes, it's asking it to write it as a plus b root 5, where a and b are rational. So what I have to do now is just rearrange it into that form. Well, if I take out the this part, the a part, that's going to be 5 over 2. Okay, so it's equal to 5 over 2. Okay, and the other part, so I'm splitting this into two fractions, 5 over 2, and the other part is 3 over 2 root 5. And I write it like that, plus 3 over 2, and then the root 5 next to it. Okay, because it's then presented in the format that the question was asking us for, which is this here. Okay, and that completes that question and that introductory video on Surds. Some quite tricky Surd questions in there, so that covers everything you need really for your first year of A-level. Okay, I hope that was helpful. Take care.